So in question number 2, let's not try to overcomplicate things. Let's keep going with what we saw in question number 1 about inverses. In letter A, it points out that in Unit 6 we actually learned 2 different ways of finding an inverse. We did do the switch x and y thing, but we also talked about another method. That was the method of writing out all of the original steps and then inverting the steps and doing the opposite, which we usually did in a little table of values sort of thing. At the time, it made a lot of sense. But for some people, it's hard to introduce this method with logs because it doesn't really make sense to them how logs fit in to the overall set of opposites that we've been doing. So I'm not going to recommend that we use this method for log problems, only because it's not as easy to explain. If we were in person and had some chances to really talk about it in class, I would definitely do so. And if it's something you want to pursue on your own, you're welcome to try. But let's, for now, just assume that the way we're going to do all of these inverses is going to be the switch x and y technique. That way we have one technique that we know for sure works 100% of the time. So instead of picking a method, let's just skip part A here and go straight to part B. Let's just stick with the method that worked in number 1. I copied down my steps just so you can see them here. We're going to switch x and y and then get y by itself. That's going to be our inverse method. So I'm going to look back at my equation and I'm going to switch its x and its y, which means instead of y equals, I'll write x equals, and then I'll copy out the rest of the problem, 3 plus log base 4 of, instead of x, I'll make it a y. So that's step 1, switch x and y. The second step is to get y by itself. Now, if you're still pretty comfortable with algebra, getting y by itself may be totally instinctive. You may be looking at this and saying to yourself, oh, I got this, I can do this, this is easy. If not, then you might need to think about what we've talked about other times this year, where we've had some choices about what to do. Some people actually preferred to do the order of operations backwards. We called that SADMEP at the time. And if that helps you get a little bit more guidance, a little bit more structure, feel free to try that as a guiding principle. That means to get y by itself, you'll follow these steps. Whatever you can do first, to do it. So for example, first thing, ask yourself, can I subtract anything? Well, it looks like this is an adding 3, so I can subtract 3 to get rid of it from the right-hand side. That would be a good first step. Now I can't actually subtract x minus 3, so I'll leave it as x minus 3 equals log base 4 of y. Now I'll keep going and ask myself, what else could I do to get y by itself? I can't add anything, I can't divide anything, I can't multiply anything. Notice none of those things would get rid of a log. But E stands for exponents, and we know that log is related to exponents or exponentiation. If I want to get rid of a log, I can exponentiate it. That's the next step. Exponentiate means write it in exponential form. Unfortunately, this problem is a little bit backwards from the exponential form structure that we usually use, so if it helps, you can reverse the order of it. Call it log base 4 of y on the left and x minus 3 on the right. I didn't do anything, I just switched the way the problem looks, but this might make our exponential form a bit more familiar, because now the little loopy arrow thing is going to be in the same order that it's always in. Now if I think about this in exponential form, I'll have a base of 4, always the base at the subscript of the log, to the power of whatever's on the other side, x minus 3, equals whatever's in the middle there, y. Now, good news. Take a look at what you just wrote. Y is by itself. That's what we wanted. Y is by itself. There's nothing else to do. Exponentiating it actually fixed the entire thing. So now I know that my inverse is whatever y is equal to. In other words, my inverse equation is y equals 4 to the power of x minus 3. Now, just for reference, what you've done is found a perfect opposite of the original problem. And it is worth noting here that there's a lot in common with what the original problem has to offer. The original problem had a plus 3, so it makes sense that its inverse has a minus 3. The original problem had a log base 4, so it makes sense that its exponential inverse has an exponential base 4. So you'll always kind of see those opposites in play with an inverse answer, and that's sometimes how you know that an inverse answer is correct. Take some time to see if that makes sense. If it does, I'll have you try question number 3. If it doesn't, then this might be a good time to simply pause and ask yourself, is it worth it to keep pressing on? Is this something that I can understand, or is this just way above my head? Because if this feels like it's just too abstract, too much to learn online by yourself, that's okay. This is a pretty tough concept to learn, and learning it alone is even tougher. So be honest with yourself, give yourself some grace, and if you feel like it's worth it, press on. If you don't feel like it's worth it, move on to a different lesson, and don't worry about this too much, because it is a lot to ask. It is a tough idea, and the more you can do, the better, but it's not worth putting yourself under some stress just to get it done.